So let's graph the square root function, square root of 1/4 x. Now we just want to plug in some numbers in order to do this. So let's plug in 0, right? We can't plug in any negative numbers inside because it needs to be positive inside at the end. So I can plug in 0. So square root of 1/4 times 0 is square root of 0. So that is just 0. What's another good number to plug in here? Well, if I plug in 4 times 4, right? 1/4 of 4, that cancels out. That's just 1. So the square root of 4, if I plug in 4, square root of 1 is 1. And then another good number to plug in is, I'm just going to tell you, is 16. The square root of 1/4 times 16 over 1. 4 goes into 16 4 times. And the square root of 4 is 2. Okay, so I just want you to see this so that you know what's kind of happening to the graph. The index in this case, if there's nothing there, it's a square root, therefore the index is even. So let's graph it. So let's make this our y-axis. Let's make this our x-axis. I'm going to scale it to 4, 6, 8, 10, 12, 14, 16. And then I'm going to go by ones on the y-axis. So we have 0, 0. And at 4, we're at 1. At 16, we are at 2. And so this is our graph. Let's graph the parent function that we graphed earlier. And so let me just tell you it's at 0, 0, 1, 1, and 4, 2, and 9, 3. So this is the parent function here. Okay, and so we'll get to know these a little bit better, but just knowing what that looks like. So notice that just knowing how the purple graph was affected with the 1/4. Now let's talk about the domain. What's the lowest x value of this purple? Well, the lowest x value is 0, and then it goes to infinity, so 0 to infinity. The range starts at 0, and then it goes to infinity again, so the range is 0 to infinity. Let's take a look at the cube root. And so I gave you numbers to plug in, so make a table of values. If we plug in 0, so let's plug in 0. -3 cube root of 0. Cube root of 0 is 0, so -3 times 0 is 0. 1, so -3 cube root of 1. Cube root of 1 is just 1. So the final answer is -3. If I plug in 1, I get -3. If I plug in -1, do you know what I'm possibly going to get? Okay, well, hopefully maybe you got that. Cube root of -1 is still -1. So -3 times -1 is a +3. So it's up here. Okay, and then this graph looks like this. So knowing a little bit about our transformations, the negative is a reflection over the x-axis. And then the 3 in the front means it's a vertical stretch by 3. So remembering those transformations. Okay, so that's what that graph looks like. Our domain for cubics are always going to be -infinity to infinity, and the range is the same because there's no restrictions. It never stops. Our index is odd because it's a cube root. Let's talk about transformations of radicals. So we're using square root of x. Horizontal translation means it moves left or right. And so remember, when we're moving left, it's going to be inside in its opposite sign. So plus means it's moving left. If it's minus, it's moving to the right. So we're going to use square root of x. So we're going to move it 2 units to the right. So this is going to be g of x equals the square root of x. And what sign is it if it's going to the right? To the right is going to be a -2. If we're going to the left, that means it's square root of x. Left means +3. Vertical translation is up and down. So what we're doing is we're adding at the end of the function. So if you see positive at the end, then it is going up. If it's negative outside, it's going down. So let's write this function. G of x, it's going 7 up, 7 units up. So it's going to be square root of x. And then +7 on the outside, right? If it's inside, that's left or right. Outside is up or down. 1 unit down, g of x equals the square root of x minus 1. A reflection. We're going to talk reflection over the y-axis and over the x-axis. So in the y-axis, there's going to be a negative in the inside. If it's over the x-axis, it's negative on the outside. So let's try this. A reflection of the square root of x is you just put a negative inside. So what happens is the graph is going to go this way. So because the reason why that is because when you plug in a negative, this has to be positive inside, right? In order for this to be true, in order for it to work, we can only plug in a negative number. So if I plug in negative 1, a square root of negative, so let me plug it in, square root of negative times negative 1 will be a positive 1, right? So you have to plug in negatives in order for this to work out. That's how it flips over the y-axis. Now reflection in the x-axis, you just put a negative on the outside. Let's go down to vertical stretch or shrink. So it gets either taller or shorter, and we're going to multiply to the entire function. So we're going to vertically stretch it by a factor of 4. Then this is going to be 4 times the square root of x. We'll call it p of x. If it's a shrink by a factor of 5, it's just going to be 1/5 and then square root of x. Now let's talk about a horizontal stretch or shrink. So f of a times x. So we're going to multiply inside, shrinking by a factor of 3, 1/3. It's always the reciprocal. So just to kind of talk about this, m of x, we're going to multiply by 3 of the x in the inside. So reciprocal inside the radical. Okay, so that's how you do horizontal stretches or shrinks. And then stretching by a factor of 2, the reciprocal of 2 is a half. So then it's a half of x. So if you look at this example here, we didn't talk about it. This, because it's a fourth inside, we can say that it's a horizontal stretch by a factor of 4. Okay, so horizontal stretch by a factor of 4, just to kind of talk about that a little bit. It won't be tested on it, but just to kind of go over that. All right, so we're going to use that to describe our transformations of radical functions, and then we'll write functions in a little bit too.